Again, it's 1:15. We're recording and sharing screen. Go. So the plan is, I updated the schedule. The plan is to circle back and finish that superposition problem on Thursday, and I'll try, if I can't come up with the nodal solution, then what I'll do is, I'll give you as a matter of fact, this is what I'm gonna do on Thursday. I'll give you the take-home test. We'll go through the nodal analysis. And then over the weekend, do the DC. Did you hear that, Tiffany?
Yes.
So what we're gonna do is circle back on Thursday and finish that AC superposition problem. Yeah, the one that we started. And then I'm gonna give you the midterm take-home test. If I can't come up with the nodal solution, then we're gonna do that one in class, the take-home test, the nodal AC. But you still have to do the superposition AC. And you can do it over the weekend.
Yeah.
So you can
Question, if we do the nodal by ourselves and get it right, we get extra credit?
take.
I tried.
Oh, yeah. If you want. But the thing is, well, maybe I'll do that. Maybe I'll just give it to you, and then if you can't figure it out, then I can do it on Monday or something if you want. You want to do that?
Yeah, we could
I
do
mean, it's
that.
in the book, so like, we're all reasonably intelligent, I feel like we could probably figure it out.
Yeah. Because you should get the same answer. That's basically the point behind it. That's why you're doing both ways. You should end up with the same answer. So that's what we're doing. And so today I'm gonna talk about DC, Thevenin Norton equivalent circuits, and then we're gonna do lab 2 and lab 3, and that's what we're doing. So let's talk about equivalent circuits. This is lecture number 10 in our series. I'm recording now. Yes, I am recording. Ooh, 16. What are equivalent circuits? Let's talk about equivalent circuits. What are equivalent circuits?
You're not streaming to
That would help. I'm just going to abbreviate that. There are simplified models. Let's put it in red. So I think this might be on a reading assignment, or it might be on one of the tests. I might ask you this. Simplified models of the original circuit that results in the same output to the load. And then you might ask, what is a model? So model is simply a representation of an actual component, device, machine, combination of ideal components, such that the model accurately replicates the actual components. So how can we condense that? So we'll just say a representation of we'll just say a circuit. It could be a component, a device, a machine, a combination of ideal components. We'll just say A representation of a circuit or component. That accurately replicates the actual component. Accurately replicates. The actual circuit or component. So why do we use equivalent circuits? So we want to know the the behavior of the load of a complex circuit. It's very labor intensive to recalculate the circuit every time you change the load, right? If I have a load hanging off a circuit and I say, well, what is the power dissipation gonna be if I change this? It's a pain in the ass to go through and recalculate all that. You can reduce that circuit down, call it a black box, and you can reduce it down, and we'll do an example. So I'll just give you a so why? So to reduce the complexity of calculating a load, a circuit load, we'll just say. So if you said that on a test, it would be acceptable. You can, if you want, I have my notes scanned. I have them in a folder. Because this is for fall 23, the students wanted my notes. So I scanned them and put them in Blackboard. If you want them, I can put them out there. The thing is, though, they're pushing this accessibility thing.
Yeah.
So it fails the accessibility thing. So Ally, it's called ALLY. It's an acronym for something. I don't remember. It gives you a score and it goes through all your documents. If it fails, then I just say, well, I got to take it out of there.
Could have been the
Yeah, or I can put it in the student access on an electrode. If you want, I can put them out there. This is from fall, like I said, it's from 2 years ago. So let's do an example of a Thevenin equivalent circuit. Everyone has this one. So this is a Thevenin DC. So this is used to reduce a circuit to a voltage source. To a voltage source, a resistance, and a load. So the steps you go through. Determine load and remove it. Label the polarity. Determine open circuit voltage. We call it V Thevenin. You do that looking back into the circuit from the load. I gotta fix that. That's unreadable. Deactivate all power sources. Sound familiar? Actually, this should be easy now that we've gone through a nodal analysis problem. When you look at this, it'll be like, wow, this is easy. But if you do this first, it's not easy. It's not intuitive. Yeah, and they're going away from it, and it's a shame because it gives you insight into how the circuit works, how it works and how to troubleshoot a circuit. Because everything's being done with software. Some guy has to write that software, someone has to write it. That guy makes a ton of money. The guy that knows all this stuff and software makes a ton of money. All right, so what's the last step? So here, let's a VS short. This is my shorthand. VS short, IS open. You don't short your power supply, you remove it and you replace it with a short. Otherwise you blow your fuse. Oh, and part of step 3 is determine our Thevenin. From load. Not from the source, from the load looking back. And I'll do an example. Step 4, redraw the circuit. Should say redraw the equivalent circuit. That's VTH and RTH. Okay, let's do an example. All right, is everyone good? Next page. Here's the circuit. We want to make a Thevenin equivalent. There's the circuit. So step 1, remove the load. We're going to call this point X and point Y. Mark the polarity. So if you want, let's go like this. Step 2. So that was step 1. Put it. Yeah. determine V Thevenin. So what's V Thevenin? Well, this is what you're gonna have. When we get done, the circuit's gonna look like this. Let's make it purple or something. Purple. You're gonna have a voltage, series resistance, and a load. So we're trying to determine this now. So if we look at this, V Thevenin is voltage looking back this way. Let's draw our eye. Give it some eyelashes. So how do we find that voltage? This is something that bothered me when I was a student at Gateway. This voltage right here is the same as this voltage. When I was a student, I was like, yeah, but doesn't the current have to go through that resistor? It just didn't make sense. But if you think about what's inside of a voltmeter, it makes sense. A voltmeter, how does a voltmeter work? It's some big gigantic resistor, 100 megohms or some ridiculous amount. And a tiny little bit of current goes in it to measure the voltage, right? A little bit of current because you don't want to change the voltage of what you're measuring. What about an ammeter? It's the exact opposite. It's a really, really, really small resistance. Some current flows through it and you see a drop across it because you don't want to change the resist or the current of the circuit. So if you think about it that way, then it makes sense. It's like, oh, okay, some current comes through here and I'm seeing the voltage across here. So keep that in mind because if you have to do one of these circuits, it'll probably look similar to this. So again, then I'm going to go back and say, now how do we find our V Thevenin? How do we find it? It's this voltage, which is voltage divider rule, right? So VR2 equals V Thevenin. V Thevenin is the source, which is 30 volts, times R2 divided by R1 plus R2. So you get about 20.77 volts. Now we need, so now we got this, check. Now we need this. That would be number 3. 3. Okay, so we have to deactivate. We deactivate this, what do? We remove it. Deactivate the source. If it's a current source, you remove it. If it's a voltage source, you put a short in its place. You remove it and you put a short in its place. You want to force that to be 0 volts. I want you to be 0 volts. So I'm going to make you 0 volts. I'm going to take you out of the circuit and put a wire there. All right. So what do we get then? We start here. Here's our little stick man. He's going to walk that way. We walk through the circuit and come back. And we want to know what the resistance is. So what do? We go through an R3 And then we come to this node, and then we could either go through R1 or R2, and then we come together. Oh, this is something I started doing too. So if we go through R1, we come to our terminal right here, where we removed our, I usually just draw that in there because sometimes you might need that voltage or current. I just draw two circles with a line. That's where we removed our R2 and through there. And then in parallel with that, R1 is R2. And then we go through R4. So we have 10K, 20K, 45K, 65K. So RT is 10K. $10K plus 20K in parallel with 45K plus 65K. That's 88.8K. So now we're at the last step. Last step, redraw the circuit with the values. So let's do it. Thevenin is 20.77. Our Thevenin is 88.8K. Our load is 33K. Okay, so that one's done. We did that. So what if we wanted to know the voltage across the load? Just a simple series circuit, right? Yep. So that would be, yep. Or if I want to know the current, same thing. It's just a simple series circuit now. Yeah.
But you can just divide 5.6.
Or power. Or if I ask you to calculate the power and load. Yeah, you could say V squared divided by R, or you could, if you had I, you could say P equals IV or whatever. It's just a simple series. It's just two components. And that's the point behind it. That's why we do it. And if you wanted to think about it, it's like, well, how does this relate to the real world? Think of this as, here, let me erase these check marks. Think of this whole thing as a power supply. And we're going to talk about this when we learn about maximum power transfer. So that's like a power supply, and then this is the load. These are the terminals on the power supply. So there's some series resistance in there. The higher this is, yeah, if it's high, then you're not going to be able to regulate very well because you're dropping a bunch of your output across it. You want it to be low. We'll talk about that when we talk about power transfer. So what do we have? One. So we've all, yeah. So let's do Norton. Then we can take a break, and I'll give you the labs. Lab 1, lab 2, and lab 3. So Norton DC. Everyone has this one?
Oh, yeah, this period, yeah. It also helps us with these.
So Norton is used. Norton. So what did I say? I said what it's 7 was before. So Norton is used to reduce a circuit to a current source, resistance, and load. So step 1, it's just like the other one, determine the load and remove it. Except I'll replace it really short. Because we want to find the short circuit current. We want to find the current through there when we, and I'll show you. Like before, we wanted to find the Thevenin voltage looking back. Now we want to know the current going through the load. So let's look at step 2. Determine ISC, I short circuit. Current through load. Three, deactivate current sources or power sources. And determine R Norton. So it's same as art 7. And last but not least, redraw the circuit. It's I Norton and R Norton. Okay, I think I used the exact same circuit. Oh, shit, what did I do? That's some kind of shortcut going there. Touch something. I think I touched this with. I don't know. Let me know when you're good. Everyone's good. So it's the same circuit as the last one. So the first thing we do is remove the load, just like before. Maybe we should put our polarity in there. Except this time, we're gonna replace it with a short circuit. Now instead of calculating the voltage here, we're calculating the current there. And I'll draw I short circuit. That was step number 1. Remember, here I'll do it in purple again. Our goal is going to look like this. Now we're going to have a current source, a resistor, and a load. That's our goal. Let's see. Move on. Step 2, determine I short circuit. We need to find that current. A good starting point would be to find IT. Find RT. Again, there might be easier ways. This is just a methodical way that I do. I just try to be methodical so I don't make mistakes. IT is VS over RT. RT. Now remember, this is RT going this way. Just write it out, 20K plus 45K in parallel with 10K plus 65K. Wait a minute. Oh, in my notes, I just wrote 75K. Do you see it? So we go here, we either go this way or we go that way. We have to come through here because we removed our load, replaced it with a short. So 45 in parallel 75 plus 20 is 48.125. Okay. IT is 30 volts or 48.125. That's 0.623 milliamps. Can you hear me over the fan, Ethan? Can you hear me over the fan? Touch and go away. So that was step number 2. We're not done yet, though. We have to find out.
Isn't that a kilo ohm? So shouldn't that be microamps?
Oh, yeah, it's K. Sorry. So I've been giving this lecture for 2 years and no one told me I made a mistake there. I have to check.
No, it's right. I mean, it's the right answer.
Oh, yeah. 623 microamps.
Yeah.
0.623 milliamps.
Yeah.
All right.
Oh, yeah. Shoot. I didn't even see your point. I was just looking wrong.
What?
Oh, I just didn't see that you put a decimal place in front of the 623.
Yeah.
That's
Okay, so we have that total current. So now we can find ISC using the current divider rule. That would be REQ divided by R3 plus R4. REQ is 45K parallel with 75K. I'm not gonna write it out. I'm just gonna add up 75K. It's 28.125K. Oh, sorry. So IT is 0.623 milliamps. REQ is 28.125K. R3 plus L4 is 75K. Should end up with 0.234 milliamps. That's ISC. Now step 2 is done. Now let's find R Norton. Step number 3. What is it going to be? It's the same as the last one. I'm not going to go through that. You can look at your notes. You start here and you look that way and you come back. 88.8 K ohms. So now we have everything. We can fill it in. I Norton is ISC, which is 0.234 milliamps. R Norton is 88.8 K. RL is 33K. And then we needed to know VRL. How do we do that? We just say RN in parallel with RL times IN. B equals IR. We know I, we know R, and we can find V. Or you can, there's different ways you can do it. So you might be asked to calculate the power. So you need to know the voltage. V squared over R equals power. Yeah. Or you could figure out the current going through there. There's all kinds of ways you can do it. So that's Thevenin and Norton. You should be able to do the DC. I don't know which one. I gave you that sheet. Let's look at it real quick. Take a break. Then we'll do the labs. I gave you that. So I got Thevenin Norton DC is homework 5. And then Thevenin AC is homework 6. Slab is easy. Those of you who are in software, I don't remember, we may have done this exact lab. Like, that's a new course that we added to the curriculum.
Okay.
So we added the course to the curriculum for molecular weights. I give you a free.
This is taking,
You do it all for us.
this is taking me back to DLC.
I can give you a lab 3 if you want one. So let me know if you have questions. I don't know, Octave might already be on here. No, I guess it's, maybe. Yeah. Yeah, it's on here.
In the back corner.
So if it's already on here, you got lab 2 is done. Plan. Let's look. You can update it to the latest and greatest, I guess. What do you want? It's gonna still work. Three. 325. Oh, there.
It's like a notebook.
7177, I think. Let's see if this works. Why that's doing that? So let me know if you have questions. Is everyone familiar with MATLAB and Octave? Maybe Blaine, maybe you're not real familiar with it. If you read, yeah, we use it once. And if you go to landfill, you'll use it like all the time. Yeah.
My computer's not allowing me to connect to it.
Yeah, same here. It's the internet connection.
What's weird?
If you go to Aqua,
Are you using Firefox?
I'm using this. If you try to go to aqua.org,
Right. I could download it, put it on.
it stops at check with the proxy firewall.
Is that a GNU Octave, that little blue circle with four squares? Is that it?
You can see in the bottom right, OneDrive.
Oh, it's this.
OneDrive is connected.
This
No, it's fine. I can access stuff.
Wait. Yeah.
Everybody funnel.
Oh, right here, GNU. You see this one?
Yeah, that's what I was.
That's
Oh, it works now. Okay, it must have just been down shortly.
I have to, it says GNU Octave UI or GNU Octave CLI.
Oh, you're right. Leave me alone.
So, yeah, we talked about matrices in this class, right?
Yeah.
So MATLAB uses matrices to solve circuits, to simulate circuits and to solve equations. It uses all matrices, creates matrices. That's how it works under the hood. Octave is just a free open source. And like of the face, you don't get Simulink, you don't get it. There's a live script script editor, you don't get that. That's all features in MATLAB. MATLAB is expensive as hell. The rendition is like $100. I have, on my book, I have like 3 of them, I think, that I bought over the years, and they still work. I haven't tried them in a while, but I should try them. But for what we need to do, you just need the command line feature. You can write scripts, you can execute. You could put, for example, that matrix in, and it'll solve it for you. You type that matrix into MATLAB, and it'll split the answer. Put RREF, parenthesis, bracket, type the number, comma, number, comma, number, comma, semicolon. You don't have to do all that shit.
Where are we supposed to download the things? Are those supposed to be it?
Oh, I have to send it to you.
No.
I forgot to send it to you.
Oh, so many of our classes, if we turn something in person, Blackboard, turn it.
When I grade it, Doug, it'll be completed because I'll put the grade in. Yeah. Yeah, you don't have to put anything in there. You can put a note in there if you want. But once I grade it, the grade will, come up in Blackboard. It'll show it, be shown as done. So let me see. Here you go. Forgot what I did. I think I sent them to you last time. Let me find them. Oh, yep, right here they are. So they're real small. They're just text files. They're ASCII text files. So let's just, maybe I'll just attach them. So we want to. So this is lab 3.
And there you go. It helps if I don't end up with this. If I click on the actual installer exe instead of like.
So those files I sent to you are script files. So we're going to write a script with Dr. Strangeway, and we're going to call some of those, we're going to use some of those scripts in our script. They're just handy things for converting from polar to rectangular. And you can open them. They're just ASCII files. Here, let's look at them. So here's a complex number calc. We'll open it with Notepad. It's just a text file. That's what it looks like. Every place you see the percent sign, that's a comment. MATLAB ignores it. select clear, CLC, then format, then it basically just goes through and converts. I think it converts from just does some operations. All these commands that you see in this script, you can type at the command line. You can type the command and hit the enter key and it works. It's just basically it's a collection of a bunch of things that you would want to do at the command line. It saves you from typing.
This is the seal.
Yeah, so what you do is it's gonna be like in user programs or so let's go for it. See. Program
I
file.
can forward them down.
GNU Octave. Yeah, I put them in 8.3. So what is it? Program files, GNU Octave. And then you'll see, and then just put them in that bottom folder.
Program files, body.
Program files. Okay, in the left on.
So just into that octave.
Okay, so do you see where so you go program files, GNU Octave, Octave. I have them in 8.3. You can put them on both. Just copy them and paste them in here too. I have two versions in here. From 2 years ago, last year. Well, here's what you could just detach them from the email and paste them in here. Create a folder on the desktop. MATLAB scripts or Octave scripts. Create a folder. Detach them, paste them in there, and then copy them and paste them. I guess you can't put stuff on the desktop because it won't let you.
The first lab. Oh, hold on.
Here you go. You want lab 3, Kaden?
Oh, where's your bills? The library.
They have 3 math. I got one.
I'll give it back to you. I'll just look at it. Oh, yeah. You have more of these or no?
This one's focused on-
Oh, okay.
Services and all that.
All right.
And one for bonuses and one for more business side.
Let me know if anyone's stuck and you can't get something to work.
I have a question. I tried just copy pasting it, didn't work. Do you have this somewhere, just like by itself, or you can send it to me? Because it's gonna take, I don't type good. It's gonna take me forever to write that all down. This is the second one.
Oh,
Do you have that somewhere or no? Just in the, if it's in the lab, that's okay.
yeah. Oh, yeah. Maybe,
It's just a lot
The
easier
word
to
that-
copy
here.
paste.
yeah. Oh, yeah. Just open lab 2.
I say I did, but it wouldn't, 2B, I think. Or 2A, I'm not sure.
It's a Word document.
Oh, open it. I was trying to copy paste right there. Never mind.
Yeah. So download it.
Yeah, download it and then copy paste.
I'm not allowed to move. Like, administrator position.
So if you. I remember we ran into this last year and then you just, it prompts you and then you just like say ignore and just do it anyways.
The only issue is.
I think it warns you or something, or it just won't let you. Well, it's the privileges. They won't give admin privileges to students on these
We
workstations.
struggled with that when we did PLC.
But last year, everyone was able to copy it. It's like a prompt came up or something, and you just said, okay. So you have the same problem. Were you able to copy it?
I just had to expand.
When it down, the automatic pull up, there's a white screen, when most stuff inside. I'm not sure.
Oh, yeah, this is a command line.
Bottom left.
Yeah, when you download it, it says GUI, one says GUI, one says CLI or something like command line interface.
Oh, and this is where it's nice to have. Like with computer. Extract it. Good brother. Yeah.
I type like this.
Yeah.
So-
There. So,
This is why you might get a laptop with the 24-core processor. It also came stock with the video Quadro 8000. You see, the only issue is when I was in back that best performance on battery is I used 3% like a minute. If you use it balanced, it does things slower. Usually 8 hours of average use out of it. Yeah, actually, this is Dell, Dell Precision
Holy moly, this was written in 1966.
5680. I got it on clearance because they were coming out with the 25 models, 4 model. So, or technically the 14th, yeah. So, this before
precise more about what it was.
UI makes this 60. Yeah, oh yeah, yeah, it is useful, 'cause it's kind of cool, it's that
You see it explained a different way. And you see the circuit drawn differently and it kind of. Just backspace. Or highlight it, hit the delete key. Not when you're at the command line. Remember, a script is an ASCII text file that you're running from the command line. But you can be at the command line and just type stuff. If you type a command and you make a mistake or something, hit the enter key, it'll give you a syntax error and just type it again. If you've already typed it, you know. So you're doing lab 2?
Yeah, I can write it out as a picture, and when you bring it to Word, it's a picture, and we'll let you pop it in here.
Well, oh, I see. It's an image. Yeah. So you have to type it out. Here, so let's find it. I got this from Strangeway, so it is what it is. I don't think I have the original document.
So if you're. Okay, but
Oh, I put a G instead of.
did you download the email?
I haven't got stuff. I'll have to do this one first.
Well,
Yeah.
he gave you it. Taking this.
So last stretch.
So you don't have to put spaces. You just type it in. E
Why
equals
don't you just face it?
no.
I've been typing it exactly. How it appears.
No, you just type in 8 equals 5 plus 7. I hit the enter key. You notice over here, It just created two matrices. They're one by one row, one column, but it's a matrix over here. They're variables. So it's stored that one in one variable and the other variable. Now you can say P equals A times B. Product is A times B.
Which class would be lowercase letters instead of?
I don't care.
Okay.
Doesn't matter. It still works. It is case sensitive. So when you call it again, you have to use the lowercase letter.
Yeah, I understand that.
Yeah,
I just know some features are very.
This is just practice. I think, I don't know if I asked you any questions in the lab. I don't remember. Let's look at it. Lab 2. Oh, take a screen capture of the results.
Yeah.
Yeah, so that's all you gotta do. Yep, that's all we got today. That's all, folks. I need a nice solid 4 hours to figure out that nodal problem. It's gonna be. Here's the problem too, is that one that we did in class is only a single node. Even though it has those branches, it's only got one node, so. I don't know what value there'd be in me spending hours to solve that. Maybe we'll just do the one from the midterm, because I don't think there's a nodal AC problem in the homework. There's only one in the midterm. So I'll give you the midterm on Thursday. You can do it over the weekend. The midterm take home. See when will it be due? Let's look at the schedule. So the midterm is in week 5. Okay. I'll give it to you Thursday. It's not due until the 30th. And then if you get the nodal and you got the same answer as the superposition, then you got it. You can just turn it in whenever you want. But you have what 2 weekends. It's due on Tuesday. So Tuesday you'll take the rest of the test in class. I think I even made it 30 points because I had students in past cohorts of students who chose not to do it. So I figured, well, if you're not going to do it, then the highest grade you can get is a C. You know what I mean? If you just skip it, then you have to get all the problems right on the written test and you'll get a 70. Just be glad it's not in the written test because you'd be sitting here for 3 hours. You'd be here for 3 hours. That's, to me, it's not productive to stress out students like that. I'm not gonna do it. I didn't like it when it was done to me, so I'm not gonna do it to someone else. I can show you my test from when I had Dr. Strangeway as a professor. They were bad. I mean, I got like these.
It says. About what we got calculator. Oh wait, no, you can just.
Just do a screen capture of this.
Okay.
Just to show you that. I just want you to do it on your calculator just so you can understand. Does everyone know how to do the TI-89, how to convert?
Yeah.
How to convert from polar to rectangular? So, here, I'll show you.
Oh, yeah, I still have this. You gotta run that.
You know, I saw this Casio up here. This is the Casio that I don't know where it came from. Use this if you want. This is the alternative. It's Casio FX-115ES. If you look at it, there is a angle on here. Right here. There it is.
Yeah. Mine is like,
You have to do like.
you have to go over, yeah. you have to like this. Get put into folders basically. Yeah, this is all.
I saw it up there, I don't know where it came from.
Yes, you remember my still be here all that time.
So we got- So what do we want to convert? Let's convert. So we'll convert 5 plus 7 to polar. 5 plus 7, 9.
Remember, that's it for the day, right?
Yeah.
I'm gonna be back, but I'm also gonna go grab some more books.
Or mess it, I should have let you guys know.
No, it's brutal. Yeah. Yeah, that's brutal, Jason.
I'll be back.
Might as well go. You might see something you want. You know,
Yeah,
if it's free.
Well, I always got to do that. All right.
You guys know how to do that, right? Convert from rectangular to polar.
Yeah.
So if you go to mode and you put it in, you put complex format in polar, and you type a number in,
Yeah.
it'll put it, type it in, just hit enter and it'll convert it. And then if you want to go the other way, then you change the mode to rectangular. So you change this to rectangular, and you can go the other way. So let's put in 8.6 angle 54.46. There's rounding error, but right? Shut this recording. No, I did. Maybe I just stopped it, but I didn't end the meeting.